post this to YouTube. All right, so I guess I'll say what I said a moment ago, that we're going to be talking about Bayesian networks for the rest of the semester. All right, so a Bayesian network, think of a graphical network like in graph theory. How many of us have taken some form of graph theory course? Now, when I say graph theory, it could be like real basic. You know, you've got nodes and you've got edges. All right, so what we want to do, we want a statistical version of that. Now, there are tons and tons and tons of packages in R that will build graphical networks for us. And they work really well. They have a lot of nice features, but there's one critical problem with almost all those packages, is that we have to know the structure of the graph beforehand. So in the standard way of approaching it in statistics is that we have like we know that two variables or more have a statistical relationship between them. We draw a bubble on a graphical model and we put an edge between them, indicating that there's a statistical relationship. Well, the whole premise about that in the vast majority of graphical network packages is that the user, the model builder, has to already know the connections beforehand. That's really not a data-driven approach. I've only found one good package in any package, honestly, in any platform for handling the situation that I want a graphical model, but I don't know the structure, and that's the bnlearn package here. Now, when do we want to use Bayesian networks? All right, so Bayesian networks, we want to use those when it's not clear which variable is predictor and which one is response. It might be that on some situations, variable A will be the independent variable, variable B will be the dependent variable. Other times, variable B is the independent variable and variable A is the independent variable, that they can switch. And so if we're in the situation where I have lots of different variables and some situations will call for one of them to be the response, others will be the predictors, and I need flexibility on which one is the target, the bnlearn package does a good job of handling that. And so the big idea here is if I don't know which variable is the target variable, or I need flexibility on which one's going to be a target variable, this is a good situation to be in. Now, this flexibility comes at a cost. All right, so if I need the latest, greatest, best predicting model I can for a target variable, the bnlearn package is not going to do it. It is flexible, it has a lot of power, it's good at detecting overall structures, but the structure that I'm going to, or the modeling power that I'm going to present to you is not the strongest that we can get in terms of making a prediction on this variable right here. So I'm gaining more flexibility with more variables, but I'm losing predictive power. And that's a good way to go with it. So if that's the right thing for the situation I'm in, it's a good way to approach things. So graphical models treat all variables as predictors and all variables as responses. All right. Now, the bnlearn package, the reason why I really like this is that this does the structure learning for us. What this does, this goes and this figures out the relationship, roughly, statistically speaking, using data, what's the relationship between variables? This is, in my opinion, the strongest aspect of this package. Now, the bnlearn package, it's not accepting of all data structures. It wants numerics and it wants factors. It doesn't want ordered, it doesn't want strings. And so you need to make sure your data is in the right format for the bnlearn package. Now, another thing to be mindful of is that it does have algorithms for fitting factor and numeric, but those are not the strongest ones. My opinion is that you really want to, if you're using this package, you want either all numeric or all factor. So if I have several numeric and like one factor, and you either need to get rid of that factor or I need to convert all my numerics by interval binning into factors.
You said order. That's more like that's like a base type block, right?
Yeah, so when I say that, that's factors with ordered equals true.
Okay.
Yeah, so just to show that. So normally the ordered parameter in factor is not present.
Yeah.
If you put this to true, that's saying that you have something like first place, second place, third place, low, medium, high. Like there is inherent order. If I don't have it, if this is false, we're in a situation where it's like Miami, Orlando, Jacksonville, that they are, it's categorical data, categorical levels, but we don't have an inherent order off of them. All right, so let's go ahead and run through an example. I prefer to do examples to show you how to do it more than anything else. And so we're going to use the Hail Finder package. We're going to use the bnlearn, sorry, Hail Finder data set from the bnlearn package. And so here we can see, if I look at this data set, I've got a lot of factors going on. This is all categorical data. Here we have date ranges, which we'll be treating as categorical also. And so we can just, I believe this is all categories. All right, so now what I want to do here, I want to just do a really fast, really quick graphical model just to show you what I'm talking about. Okay, so what's going on here is that in this setup, we're saying that the variable that's higher up is like the variable that is the predictor variable of the one down low. So here, this contradicts what I said previously, that so what we're saying with this variable being the predictor variable of this one, the one that's high up, predictor, lower one on the arrow is the dependent variable. All right, and so here, this immediately gives us a structure on this, that we can see the variables high up predict, like this one's a little bit lower, which predict the ones that are a little bit lower, and keep on going all the way down. Now, let's think about the predictor response relationship for a moment. Is it fair to say that temperature predicts ice cream sales? Is that a reasonable thing to say? Yeah, this time of year, ice cream is definitely selling and selling fast. Now, from a data point of view, let's say we knew the ice cream sales, but we didn't know the temperature. Could I get an inference on temperature from ice cream? If I saw that, let's say that I had a whole bunch of data about dates or about ice cream sales, and I'm working for like Ben & Jerry's or something like that, and I see that ice cream sales were absolutely terrible. Can I get an idea of what the temperature was? Yeah, right. I mean, and if I see that the ice cream sales were great, just flying off the shelves, probably probably a hotter day, and can we build a model to, in reverse, have from a functional algebra point of view, can we build a model that says temperature depends on ice cream? Yeah, now we know it's going backwards, but for the purpose of inference, that's fine. All right, so so what we're going to do is, if this variable, which is pointing down to this one, so if this variable is the one I want to make an inference off of, I can use this as the predictor variable going in the opposite direction. And so what will happen with this? Let's say that I need to make an inference about this variable all the way down here. But all I know is this variable here. All right, so if I know this variable, it's going to change the conditional probability of this one, which will change the conditional probability of this one, which will change the conditional probability of this. Subsequently, these variables, and it'll keep on going all the way down until I get to here. Okay, and so I can use any variable up here to predict a variable down here. But it also goes in the other direction. If I know the conditional probability over here, remember Bayes' theorem? Bayes' theorem basically says that knowing one conditional probability, I can switch it, the probability of A given B, I can use that to get inference on the probability of B given A. I can use Bayes' theorem to get inference on this, which will give me inference on that one over there. And so one of the true powers of this is that when I have incomplete information, I can still use this model. Think about your linear regression models. If I'm missing one predictor variable needed for a linear regression model or generalized linear model, I can't make a prediction. I have to impute. Here, the bnlearn package will go ahead and figure out things for you. Now, it might give you just a probabilities. It might, it won't, if you have incomplete information, it won't give you complete information back, but you can still get modeled value. You can get like a most likely value back. And so this is a very powerful in a situation where when I have limited information and I need to make an inference. And so with this, let's say I have information that comes in, I know I'm gonna have missing values. I know that I'm not gonna have all the predictors I would like to have. Whatever I get, I'm just gonna drop into here and go with it. bnlearn lets us do that. And this makes it really powerful. Any questions about this? Now, this is really hard to read. It gets, we'll talk about ways to make this a little bit easier to read in about an hour. So how do we even get this? All right, so this model here I'm using the hill climber function in the bnlearn package, and I'm just dropping the data set. There are several different ways to fit a model in bnlearn. They have several model fitting algorithms. Consistently, HillFinder HC comes up at towards the top in my experience. I don't have like, theoretical knowledge, theoretical, work on that to prove that, like from a math point of view, but from my experience of building models that work, HC tends to be the best performer or nearly the best. So I tend to prefer to use it. Now the graphviz plot here, this is just the function for plotting these. Any question about these? All right, another thing we might want to know about is how strong are those statistical relationships? So in terms of the relationship between two different variables, I want to know, is that a strong relationship or a weak relationship? Like, like if it was any weaker, we want to get rid of it. Well, what we can do, we can use the arc strength function to measure how strong is the relationship between the variables. And then we can use a strength plot. Now you'll notice that on arc strength, I give it the model which has already been built, and I give it the data sets that I want this to be built on. So notice that this does not have to be the data set that the original graph was built on. So it might be that I believe that there's a model structure and I have that model built up. Then later down the road, I get new data. I want to check to see, does the graph that I've already established correspond well with the data I have looking at. So here, this model, we could have built that manually with subject matter knowledge. We could have gone through, we could have built it using the bnlearn package functions. We may have built it with bnlearn and then modified it. And then here, it's like, hey, does this look like it's a good, solid match? Does it look like I can trust this? And then we do a strength plot. So here is the strength output from up above, and I'm specifying the model. So the thicker arrows have a stronger relationship. Now, when we talk about our arrows, so the arrows are our connections between variables. There's three types of arrows we can have in our plots. First one is that we could include an arc when we shouldn't have. Another one is that we don't have an arc that we should have had, or we could have had an arc pointing in the wrong direction. Now, of these three, the wrong direction is the most prone to happen as you work through this. Why is that? Well, remember that Bayes theorem aspect? That the probability of A given B is proportional to the probability of B given A. All right. So conditional probabilities, if I switch the order, they're proportional to each other, no matter what happens. All right, because of that, it's possible that from the data just kind of indicated that one was stronger than the other. And therefore, it could get it in the wrong direction. Also, the algorithms work to make sure that we don't have any cycles in our graphs. So if I look at this, do you notice that there are no loops? After I leave a node, it is not possible to follow the arrows and get back to a variable I was at. Do you notice that there are no cycles anywhere in here? If I go the direction of the arrows, I can never return to where I was. This is called a directed acyclic graph. The reason why we do not want cycles is that we don't want echo chamber effect aspect. All right, one of the major disadvantages of the bnlearn package is that there are multiple object classes for nearly the same purposes, and which I find this maddening as I work with this at work. So something that we need to be able to do is we need to be able to convert between object classes to be able to get the full power of this. So what will happen is you fit a model in one algorithm, then you want to use a particular feature, and that, some function that's useful for what you're working on, but it won't accept it directly. You have to do a conversion in between. All right, so here, one of these is to do a bn fit. So here, this is the model stating what is the relationship, what is the directional relationship of the graph. Now, at this point, when I have model hail finder, this tells me which variables are on which ends of the arrows, but it does not tell me the fitted model relationship between the variables. So at this point here, when I fit this model, I know the connections between the variables, but if you tell me a particular value for a variable, I can't use that to make an inference on any other variable yet. I haven't actually fitted the values. How the bnlearn package works: if I have 100% numeric values, all these arrows are going to correspond to a linear regression model, multiple linear regression. If all of my data is factors, then what it's going to do is it's going to set everything up as contingency tables. My opinion is that this package works best off of the contingency tables, which is less informative than the regression models, but it's, you still have the regression options. All right, so what this step does is that this actually sets up what precisely is the relationship in terms of coefficients or contingency tables between variables. And then we have several plots that we can use to get a better feeling. You can't see it here because it's such a large graph. There's so many variables. But what's happening here is that it's showing bar plots of each of the variables through here as we trace through. And if you're working at home with the code, you can zoom in and get a better view of what's happening. I usually don't use this at work just because it's too scrunched up. Now, if I put graphviz chart to dot plot type, then I get something that's nearly the same. The difference is inside here. Bar prob, what this does, this will give us the empirical probabilities for the univariate variables. Now the actual model fitting part. When it comes to actually figuring out what is the structure of the graph, where are the arrows between the variables? We have all these options in bnlearn. And of course, when I have multiple options, some are going to be better than others. The ones up top are the ones where I've had the most success with. I've never gotten Chaolu or Arcane. I'm not saying that right, but I've never gotten these to really give me any good results at work. The ones that usually come up on top are Hill Climber and Taboo. They're very similar algorithms. Then the rest of these are usually competitive, maybe the best for the individual project. So something that is nice about bnlearn is that it will do cross-validation for us. So we can just run it and work on it. So what I want to do now is just run through an example just so that we can see what does it look like. So what we're going to do, I'm going to do a bunch of different cross-validations. I'm going to put them into one list because putting them all into one list makes it easy for me to work with in my workspace. And I'm going to use bn.cross-validation, Hailfinder data. Here I'm just specifying which model it is. I'm doing cross-validation 2 folds, and I'm doing repeated cross-validation twice. So I'm going to chop my data into 2 groups, 50-50. One half is going to be the training data set, other one will be validation. Then other one will be training set, validation, get cross-validation statistics. And I'm going to do that a second time. I like 2-fold cross-validation because I have completely separate training data sets. And so we can see what we've got. And we can see our standard deviation of the loss and our average loss over the run. And we can look through and to see what's going on. All right, now I actually want to take a look and see, all right, which one did the best for me? And so this is kind of ugly code, but I'm going to go through and I'm going to get the average of the loss for each of those runs. And so I've got four times I built a model and checked the validation statistics, and I want to see which one is the best. And this code just goes through. The hard part of this is having to go through and extract the loss off of each individual one. Because we've got multiple, we have multiple runs and multiple folds to go through. And these for loops take us over So this for loop takes us over each of the different models. This for loop takes us over a run, I believe, and this one takes us over a fold. And then I'm taking the average of it. And so here we can see that we have the lowest loss on hill climber and then taboo and then down the line. So we can see the grow shrink algorithm was our worst performing guy on this one. Any questions about this?
When you're getting the loss, that's not your standard deviation, it's just a straight number.
Yeah, it's just a straight number. All right, so after I built my model, I want to have a picture so I can look at it, so I can check to see, does this make sense? So we'll use the actual visualization as kind of like a sniff test. Does this make sense? Also, where I've had the most power and the most impact using these models is not with the actual statistics relationship between it or prediction. It's telling people the relationship between variables when it's not clear, even to the subject matter experts. So I have made quite a splash at work by visualizing the graphical model and then showing just that. I don't even tell them the linear model. I don't tell them the contingency table. I don't tell them the AIC or BIC or anything like that. I just tell them a picture of the nodes and the arrows. And when I've done this, and I've shown it to subject matter experts, the very first time I did this, I put it up in front of a room like this, and all of a sudden they looked and they started nodding their heads. And that's when I knew that this was a good way to go. I kind of learned about graphical models on my own, just studying it, thought it was interesting, tried it. My boss thought it was good, so we went ahead and showed it to our clientele, and then boom, it took off. All right, so we need to we need to create, it's misspelled, visually appealing and informative visualizations to get our clientele to buy in. And so remember, visualizations can make or break the result of your project. Our number one job always will be communication. More than anything else, we need to be able to communicate and convince our clientele. And visualizations are an excellent way to do this. All right, so what we want to do, we want to use the rgraphviz package. All right, so this is a bio-based package. This is not a CRAN package. This is not a standard repository R package. This is in the bio-base collection. And this gives us good features for plotting graphical models. Many of the graphical model packages are in the bio-base group, not in CRAN. All right, so let's go ahead and run through another example. This time I'm going to use the alarm data set. And I'm going to build a model. And when I was playing around with it before, to me, it looked like hill climber was the best one to go with. If you don't know, go hill climber. All right, so the goal right now is for us to talk about how to visualize our graphical model. And so the first thing I want to talk about are the nodes. So the nodes correspond to the variables. So each variable in our model gets its own node. And so to control this, we have nodes in the rgraphviz functions. And for the purpose of making appealing plots, I find that fill color and shape are the most important ones. All right, so how I have proceeded in the past is that I'll put shape equal to ellipse, and I'll put or a rectangle or box. And what that does, that makes it wider instead of tall. If I look here, so this is from the previous thing that we were just talking about. This is, look at the circles on this plot. How much vertical area is being used for each variable? Yeah, it should be flatter, right? So could potentially, if I could replace these circles with an ellipse, a flat ellipse, would that be better? Would I be able to zoom in more on the model? Yeah. Okay, another way would be to put a box or a rectangle around it. Yeah. So let's do that. The other thing I like to do is I like to have variables with like the same property, like have the same color. So I'll fill in the color of each node. So let's say that we have data that's related, if we're talking about athletics, maybe I could have things involving speed could be, let's say, red, and things involving strength could be blue, and the athletic events involving green could be, or athletic events involving agility could be green. And so then you can very quickly see what types of variables I'm looking at. All right, and so putting in the fill color. So the fill color is to color the background. The color will fill in the circle or the ellipse, the boundary. Fill color will fill in the shape. Now, the node attributes are labeled as node attributes in the plot function, and this needs to be a named list. So this package, the rgraphviz package, is big on named lists, and it has a particular way of just typing this out. Is the first time you work with it, it's kind of a pain in the neck, but once you get comfortable with working with named lists, it's pretty quick. All right, so what I'm going to do is here I've got my vector of nodes. So that's going to be a vector of the variables in my model. And then I need to name the vector. So everything needs to be named when you work in the rgraphviz package. Here I've got the strength of my model. Here's my number of nodes. I'm going to choose the Viridis color palette. Why is it that I like the Viridis color palette? Do we know? Yeah. It's good for colorblind. Good, good. That's one of the things I want you to walk away from this course, like knowing, like that's a good one to pick.
I remember you saying something a couple weeks ago about how you run into occasions where you don't use it until it's thin, and then you're like, okay, now switch.
Yeah, so if there's informative value in the colors, I prefer to just use the colors until there's color blindness. So if I'm in a situation of like, this is good, this is bad, I want like red, yellow, and green, because that's very clear. They understand it. If I'm in the situation where I was dealing with like fruit, I would want strawberries to be red, I would want blueberries to be blue, I would want I would want lemons to be yellow, limes to be green. I would want to match up, something that like connects. But one thing that you can encounter is one of your clients will be colorblind.
Yeah.
And then that can put you in a bad position. And so I feel like the best course of action is to keep it informative, but don't go crazy on the colors. Try to keep it down to like the fewer is better. 2 is always good. If you go above 5, you're automatically running risk. Above 7, you're definitely just like no reasonable person can match beyond 7 on most plots. All right, so here, let's go ahead and set up our shape. So there's possibility of circles, ellipses, and boxes. There's also a rectangle, but box and rectangle are the same. And then we have our shapes. And you'll notice that every single time I have to put in the name of what I'm specifying to make sure it matches up correctly. So I want to kind of skip down just so that we can see what that looks like. All right, so very quickly, just off of the colors, can you see like which ones would group together? Now you'll notice that something I did was circles are always purple, and every time I have yellow, it's a rectangle. I find that it's good practice to double up on the features. So I'm trying to just show one feature off of each variable. One thing that we would like to do when we're first learning to do this is like, oh, well, this one feature will correspond to color. This other feature will correspond to shape. And what ends up happening is that at most they pick up one. So it's better to just double up and just say, hey, pick the most important aspect, and that's going to correspond to color, and that's going to correspond to shape if you can. All right, so that is just the nodes. Let's talk about the edges. All right, now for edges, we have label, color, and font color. Okay, so when I say label, that's going to be a name that is presented on the graph. And I can give several different names. Like we might want to put like the strength of the relationship, or we might want to put the p-value from a hypothesis test. Maybe we want to put down a statistic from a test, coefficient, something like that. Here, this will be the color of the arc itself, the arc or the edge, and then the font color of the label. Edge attributes are labeled as edge attributes in the plot function. And once again, it has to be a named list. And we're going to have to be very particular about naming everything along the way. And we want to have named vectors. All right, so here, what I chose to do for this particular example is that the label for each arc, for each edge, is going to be just the from to. So the variable at the beginning of the arrow and the variable at the receiving end of the arrow. And I put a tilde just in between just to show like it's a statistical relationship. And that's going to be each of the labels of that. And then here I'm going to set up my edge colors. And so one thing that I have found is a good idea is to set up your edge colors to match the variable that's above. So the independent variable color is the one that I feel like works the best. So what I'm talking about there is you will notice that every single one of the arcs have the same color as the variable above it. Now, I have played around with putting it so that the receiving variable color goes with the arc. I felt like the clientele did not pick up on that as well when I presented that. So I feel like this is the better way to go on that. And we don't have to actually specify the font color. If we leave color alone, it will give us black. And so here, I actually feel like black would have been better on this plot, but to show you how to go through and control it, I went ahead and did it this way. If I just would have omitted that portion of the code, it just would have been black, and that would have been, good. And you'll notice that here I'm using the from variable to specify what the color is. All right, so in the world of R and graphical models, there are tons and tons of packages, and there are tons of specialized objects for graphical models. And all of these have advantages and disadvantages for what you're working on. And for me to be able to use the full power of R, I need to be able to bounce back and forth between different structures for my graphical model. And it works out that if I want the full power of the R GraphViz package, which I feel is the best way to visualize our Bayesian networks, I need a graphNEL object. So what is a graphNEL object? Really, for our purpose, it's just a particular way of storing a graphical model. If you want to look at the package, dig in deeper, the help documentation will tell you what's up. But nicely for us, the bnlearn package has a conversion function for us. And so it'll do all that work and we don't have to think about it. We don't have to worry about it. And so I just drop it into there.
So, sorry, when you're talking about that bnlearn, it's gonna have an override for ads, right? Some kind
Yes.
of thing, and then when it knows to tell it to talk, are you saying that that override explicitly knows how to talk and convert it to graphNEL? Or is there, it's just serialized string, like graphNEL does, or some kind of intermediate format?
Yeah, so what this does is that so the bnlearn package has particular object structures that it stores its models in. And so that format, all the information is there, but it's not in the right format for another package to be able to work with. And so what this does is that it just converts it over. And I'll talk about, I don't think we do it tonight. I think it's next week. I'll talk about the ways that we actually convert back and forth. There's actually a character string representation.
Okay. What I wasn't sure is if some of these packages like bnlearn, they know what people are using, and so the maintainers of that package, they're going to read and be like, oh, well, I know that whenever someone's using this, they're also going to use, they could be using this or this. So they're going to add some special cases of like, well, I know I need to be able to make sure that this is formatted as an object to read together. And then I'm going to make sure it also, set up for X, Y, Z.
Yeah. So I think there's probably about 5 other packages that the bnlearn package will convert over to. I'm pulling that off the top of my head. I mean, there are multiple, and those are, from what I can tell, the most common classes and object structures for this realm within the R sphere of data science. All right, so when I'm plotting my model, I have several different ways that it can get slapped down. All right, so here, what I want to talk about is how does R actually choose this variable goes here, this variable goes here, this variable goes here, this variable goes here. Like how does it decide where to place each of the nodes on the paper? And so our options are dot, Nito, 2Pi, Circo, and FDP. The default is dot. So the following plots are going to be all of the same model. So it's the same model, but presented in a different way. Now, if I look at this model here, notice that, what I could have done? I could have taken these 2 variables right here, and I could have switched their positions, and it would not have changed the model at all. I could have taken this point here, and I could have dropped it way over here with the arrow getting stretched. It would not have changed the informative value of the model. I could take this node here, I could drop it down, way down, and from a modeling perspective, we have the same presentation. And so we want to, basically, we have different options of how this gets slapped down. So here, this is dot. This is the one that I like the most. And the reason why I like it is because it's always top down. So that makes it easier to interpret, it makes it easier to read. Now here is Nito, same model. There are quite a few variables involved in this, so it is quite crowded. But here you can see a different structure, like things are kind of moving outward. Like the previous one, it was all very top to bottom. Well, now this is, we can see it's like trying to have like a flow going on. And here it's easier to see like groups of variables. Now 2Pi, getting a little bit complicated. One of the reasons why I like dots is that you see that it also tries to not have crisscrossing. Now, Circo tries to make things circular. How about that? I mean, I would, if you have told me get a circle going off of this, graphical model, I would not have thought to do that, but I figured it out. An FDP. Now, all of these have advantages and disadvantages depending on your project. And so honestly, before I show something to a client, I run through all of these. And I just take a look, does one of these have a piece of information that just absolutely pops out? And so it might work out on your project that you look over here, and from subject matter knowledge, that these are all there's some special relationship between these variables. And that would jump out at you and you'd be, hey, I want to show this one to my client. Any questions?
Yeah. Can you explain what those isolated values mean in terms of this representation?
All right, so this is saying that in terms of the arrows, there's no variables predicting this one. So this is like an independent variable that does not depend on anything else.
Okay. What about the one that doesn't have any arrows?
So this has no statistical relationship with any other variable. That's an excellent question. Now, something about that. If I was to go through and say, hey, let's go through and check this variable across every other variable, I might pick up a statistical relationship somewhere. What's going on with this, something that's very important, is that this will not allow any cycles to be built up. And so there might be like relationships in here that would have resulted in like a cycle. And so the R is just saying no to it altogether. And so also something that is of concern with this is the order in which the arrows were established. And so it might be that this got left out just because it's just barely below the threshold to be included. Like let's say repeatedly, it's just below the threshold, below the threshold, below the threshold. It might be that if we took out two variables, boom, it would be included in the graph. So weird things can come and go as we change our model. Good question. Any other questions? All right, let's go ahead and do a case study. Now, a graduate of UCF's data program with the staff department used bnlearn at Animal Kingdom for a recommendation engine at their restaurants. So this is a live, real one, and from a graduate of our school. So our goal in this project is to, in a sense, repeat what they did, but we're going to be using a data set from the bnlearn package, not actual Disney data. So what we want to do is we want to check the customer's market basket. We want to do market basket analysis, like similar model, and we want to recommend an item. Okay, so what we want to do for this, I like graphical models for this purpose. The reason why I like this is because I don't have to worry about anything like lift, support, or confidence. When you talk about market basket analysis, you have to figure out your lift, your support, and your confidence, right? And it's just, to me, when if I'm going to like choose, try to choose those, it's hard to figure out where are the good cutoffs. When are the rules useful? Instead, I like graphical models because in any situation, I can get the probability for all other variables that are not in the basket. So the idea here is whatever I have in the baskets is going to be the predictor variables. So we're going to have ones and zeros. 0 for not in the basket, 1 for in the basket. We're going to make a prediction on the probability of an item being in the basket when it's not. So every time that we have 0 items of that in the basket, we're going to predict the likelihood of it being in the basket. If it looks like it's likely to be in the basket, we recommend that item. And our goal is to get the client to buy one more item. And then once they buy that item, we're going to try and get them to buy one more item. We're going to repeatedly upsell them until their wallet is empty. All right, so we want to create a model that identifies what a customer would be prone to adding to their shopping baskets. And our point of view is that we want to find the one item or a select few items to get into their basket. The moment they put that into their basket, we're doing a new prediction to update. So we're going to do a conditional probability model. And I feel like a major advantage of this approach is that this is easier to figure out what are the meaningful rules compared to market basket analysis.
Yeah, you saying use a graphical model, you're talking about preferred or modeling that relationship as a graph.
Yes.
Okay.
Yeah, so I'll see. Let me see, did I plot it? Well, I don't think I plotted it. Huh, okay. Yeah, so it'll be like a graph with the nodes and arcs going on. All right. The data set we're going to use is the groceries data set from our market basket analysis lecture. Now, it's not in the right format as is, so we're going to have to do some data prep. So what I'm going to do, I'm going to convert this over to a matrix, and then I'm going to convert it over to a data frame. And you'll notice that when I do this, if I just look at the first 6 rows, first 6 columns, that our columns are Frankfurter, sausage, liver of ham, meat, finished products. And we can see that the first 6 products, the first 6 baskets do not contain any of the first 6 objects. So true means the item is in the basket, false means that it's not in the basket. All right, now something that when I'm working on a smaller data project, I'll go ahead and sort things just so that it's easier for me to identify patterns as I look through the project, as I work on it. If I was in a big data project, I would not do any sorting, but here I'm not. And so as I was preparing for, when I was preparing this material, I was looking at the data frame, and just to see what's going on and scrolling through, and that helped. And putting things in this order helped me identify some features. It helped me understand what was going on. All right, conditional probability models take a long time to compute. There are some of the bnlearn package algorithms can take a very long time. Usually Hill Climber is pretty fast, but the more variables I have, the growth in number of arcs that have to be computed grows pretty fast. It's not factorial growth, but it's still like darn fast growth. Rare items that are rarely purchased are not worth recommending, more than likely. So honestly, a rare item should just be excluded from the model altogether, especially if I'm talking about a restaurant, a kiosk, Uber Eats, something like that. Really don't even bother recommending the rare items and just try to get the ones that people are more likely to grab. These will make the model more complicated. These will make it take longer to compute, longer to score, and we're not going to get the benefit back. All right, so what I'm going to do, I'm going to trim down the items to the ones that account for 80% of the items in our baskets. So this is like a Pareto rule, 80-20. 20% of our items will account for about 80% of our purchases. Roughly speaking, now if you actually start looking at real data, it's not going to be exactly 80-20, but close enough. And so frequently when we see counts, 20% of our items, 20% of our labels will account for 80% of our counts. And so here I'm just going through, okay, on this one, 30% account for 80% of the sales. And so that's going to be just 53 items. Now I converted the true and falses to zeros and ones, and I converted them as factors. All right, so something that's important about this in the bnlearn package, if it sees numerics, it's going to run things as a linear regression model. I don't want linear regression for this because this is a binary yes/no category aspect. And so I have this as a factor. What's going to happen under the hood is that when I fit the actual model, I'm going to have a ton of contingency tables. And so let's say that I have one variable leading into another. That's going to be a 2x2 contingency table. Now, that 2x2 contingency table will be used for conditional probabilities. I see that an item's in the basket. What's the probability of the other item being in the basket? Now, even though there is a directional relationship using Bayes' theorem, we can go in reverse on that. Now, if I have two variables leading into one, that's going to be a three-dimensional table, but the math still works out. And R handles all the computations for us easily. If I did not convert the factors, I would end up getting a linear regression models on the zeros and ones, which we could use, we could launch it, but we know we could do better. All right, so we have a ton of different ways that we can actually fit the model. My opinion is that if you don't know, go with HC and just run it. I benchmarked each of the algorithms on a subset of the data, and this was the IAMB FDR was the fastest among this first line. These are the constraint-based algorithms. HC was the fastest score-based algorithm, so that's just between HC and Taboo. These are the hybrid algorithms, so these are the ones that will take either numeric or categorical. And these are the local discovery. And you'll notice I have I set it up so that the fastest ones are on the left and the slowest ones are on the right for each line. And these are the ones that I have had the most success with at work, specifically that one. All right, something that is weird about the bnlearn package. What is AIC? What is BIC in statistics? Do we remember? It's a diagnostic. Do you remember how it's calculated? All right, so how AIC and BIC are calculated is that we take the log of the estimated likelihood, and then we take the number of parameters in the model, and then we combine them together to get a measurement of how, like, likelihood is how well the data and model fit together, and then the number of parameters is representing complexity. So what we're trying to do, we're trying to simultaneously account for how well does the data fit the model while considering how complicated the model is simultaneously. All right, in the standard calculation, we will go negative log likelihood plus plus the penalty terms. All right, so it works out because of that. We want, in standard calculations, we want the lowest BIC or AIC we can find. Well, does that sound intuitive? If you didn't know already, would you know that the lowest value possible is the best one? No, like this is kind of a weird way of like everything else, you know, in statistics, we always say like big correlation is good. You know, if I'm talking about model quality, you know, biggest R squared is better. Well, the bnlearn package basically did a minus sign flip on it. And so when I look at BIC or AIC inside a bnlearn computation, bigger is better, but everywhere else in the world of data, lower BIC and AIC is better. So just know it's flipped for this one special case. Also, be aware that there are different ways of computing AIC, well, actually AIC or BIC. For asymptotic convergence, there's other computations that, in terms of going towards the limit point of view, that are better than the standard calculation. So if you need to compare AIC across different functions, different packages, know that you may not be getting exactly, you know, apples to apples comparison. You might be doing apples to oranges. So this is the code that I ran to go through and execute each of the different models. All right, so if you want to be able to call a function using a string in R, you want a do call. The do call function takes a character string and then looks for a function of that name, then executes that function for you. And that's how I did this, to get everything to run in one loop. All right, so this took a really long time to compute, so I just never reran it after the first time. But I'm going to go ahead and just use Hill Climber for the model. And now here, I'm going to actually fit the model itself. So what this part of the code is doing is that this is figuring out what is the graph. Where are the arrows between different items that could be purchased from the grocery store? But that doesn't tell me what's the probability of ketchup given hot dogs yet. I know the relationship between variables, but I don't know what is the particular probability values. So I can't actually score the model yet. This tells me structure. This tells me the actual model itself. So now let's go ahead and score it. So what I'm going to do, I'm going to randomly pick some baskets from the data, and I'm just going to say, hey, take the data, pick a few, and let's do some scoring on it to see what we get for recommendations. Now, something that was kind of a pain in the neck about this is that for this particular project, the bnlearn package really was not built up for this. that the authors really didn't have this on their radar for this utility. And so to actually get the probabilities out, I had to do a little bit of work to get the predicted values, then extract the attributes, get the probability attribute, then grab the probability of a 1 instead of a 0. So a 1 means it's in the basket, a 0 means it's not. And so now, here are the predicted probabilities for each one. So here is the probability that whole milk, the modeled probability of whole milk being in the first basket. Here is the modeled probability that other vegetable would be in the basket, rolls, buns, and so on. Now you'll notice that these don't add up to 1 because this is the probability of individual items. So the idea now would be that if this was live, like a customer was actively shopping, would look through here and go, hey, it looks like other vegetables are prone to being in this basket. That means that it wouldn't, from our point of view, it probably would not take much to bump them into getting some other vegetables. So like, hey, let's show them a coupon. Carrots are on sale. Or maybe soda. We flash an advertisement that, for Coca-Cola, like right then and there, to get them to go, hey, I think I want a Coke. Any questions about this? Does it seem like a functional way to proceed? Now here, I just want to take a look at what's in there. So this code is, I'm just going through and I'm reshaping what I have so that we can see what we want to put together. So here, this is what's in the basket. This is the modeled probability of each of the other items. So let's take a look at this. We see that someone's got whole milk, root vegetables, tropical fruit, sausage, frankfurters, frozen vegetables, and a salty snack. What item would we want to promote the most?
By that chart there.
Yeah.
That's
Yeah, so we would probably say, hey, other vegetables. Okay. And we would see that UHT milk, we probably wouldn't be able to convert them on. We probably could not get them to buy berries. So one of the reasons why I like this more than market basket analysis is that I have a quick ordering on what I should tackle, what I should try to get going. Here's another one where we've got root vegetables, citrus fruit, pip fruit, coffee, and UTH milk. And we're modeling saying a 42% chance of getting regular milk. They've already got UHT milk. We think we could, by a large margin, get whole milk into there. Here it looks like tropical fruit would be one to go for. Now, we can see on this one that the top ones are all kind of tight, that there isn't much of a difference in their probabilities. Any questions about this? All right, then, why would we want to use a Bayesian network?
Just in general, if you have a data set that includes missing information or there's some stuff that you don't know, that would be
All right, yeah, that's excellent. So here, with a Bayesian network, if I know one predictor variable value, I can get at least an idea of all other variables. I don't need the full data set of predictors. So that's something that's very advantageous. So if there's like 50 variables going on, and let's say I might have situations where I see 3 values, I want to make an inference on some other ones, Bayesian networks will give me something. And the way to actually score it is in here in this this example. It is cumbersome to pull out though, but you know, it is possible. What's another reason why we like these? Why would we pick this over another model structure?
You seem to have a number of cases of graphs, so I'm wondering if there's some kind of a problem, it'd be helpful to model this graph that be solved that way, or that won't help.
Yeah, so like on just the graphical presentation is an inference, right? Like, you know, I can show just the graph to my clients, and that might be the information that they need. Like if it's not clear to them what the relationship between the variables are, that doesn't. Any other situation? Yeah.
I think the pathing structure of the network is also pretty important, going from one place to the other in just like a concise manner. You wouldn't really be able to connect one dot to another that easily using another modeling.
Yeah, like you'd have to, like, if you wanted to do it by hand, you know, without this package, you would have to find pairs that are strong, and then you start like connecting, and you might, you know, like, you know, in the situation where if I have variable A to predict C, I don't need variable B because the informative value of B is contained in A. Effectively, that can happen, and so the bnlearn package handles that well. The other situation that graphical models really come into play is when we don't know which one will be the predictor, which one will be the response. So in all the other supervised learning situations, we have to know which one's to target beforehand. Here, we're saying all variables are predictor, all variables are response. Now, another thing to remember is that under the hood, everything is either a linear regression model or a contingency table. And this package performs better with contingency tables, in my opinion. And there are 3 types of errors in my graph. Missing an arrow that should be there, or an edge. Edges are undirected arrows. Having one there that shouldn't be there, or having it in the wrong direction. And the one that's most prone is having it in the wrong direction. Do we remember why?
With Bayes' theorem, you have A conditional upon B, B conditional upon A, so you don't really know. In some cases, if you're going in the correct direction since they're proportional.
Yeah, exactly. All right, so I'm feeling good. Any other questions? If not, then we will call it a night.
I had a quick question, not on the lectures, but on
Okay.
the final project.
Mm-hmm.
So we're doing a YouTube video, right?
Yes.
Video presentation. So we're sending that to you, like, as a link. Now, the format you're expecting, I mean, you got it where you're there, and then also like you've got your presentation section. Using some like will be a studio, like merge those two together, or like to present as video. That's the
Yeah. So you're asking about software to do the recording?
Yeah, like, are you expecting a like, we just screen share what our presentation form would be, like, say it's a slide deck or a notebook or something like that.
Yeah.
Are you expecting like us to be on camera while showing that, or is it fine to have like voice guided on this stuff? It's clear. because, like,
Okay, so one thing I want you in business attire. I want, my goal is for you to ultimately, use this material to get your dream job, have a great life, have your kids have very comfortable, very enjoyable summer vacations. Your children can be spoiled brats because you have the means to make them spoiled. My goal is not for you to learn theory or to, appreciate the aesthetic of statistics. I love statistics. I love math. I love it. But honestly, I like a better paycheck more. So I want you to be dressed like you're going into your dream job interview, like at a bank. I want you to be in formal business attire. So you'll notice I am not in formal business attire. Formal business attire is like preferably a dark suit, like gray, navy blue, a black, and a monochromatic shirt that's like white, blue, gray. Think of like being a banker, and where you can have your pizzazz is in your tie and your pocket square if you want to. Now you can be like this, from the waist up. I won't know the difference, but you can. My preference would be for you to get full blown, haircut, trimmed to be, get clean shaven. I mean, maybe not clean shaven, but trim your beard, shoes, everything, because I want you to be comfortable when you get to that stage of an interview. That if you have to give a presentation to show that this is why you should hire me, which is possible, I want you to be ready for that. Also, if you have a Zoom interview or Microsoft Teams interview, something like that, I want you to be comfortable. And so if you mess up, if you bomb it, I would rather you mess up and bomb in my class than at an interview. The point of the course is to learn. If you totally feel uncomfortable and you need a few practice rounds, it's better to get that out of your system here than when your potential boss will be there. I want you to be in the position where you can choose to accept a job, yes or no. That's better than not having that choice. So I recommend using Zoom. It's ucf.zoom.us. It's the one I use for my YouTube videos for the class. And that works great. You can see that I'm using it right now. And right now, if we look here, here is my phone. I don't know if the people at home can see this, but the people at home can see the back of my bald head right now. But you could just have like a plain background behind you. Also, just to let you know, I find my personal opinion from like during COVID, and I work remotely now, is that be mindful of what's behind you. A lot of people, when they do their Zoom stuff, they'll put like a photo. To me, it's distracting when somebody's moving their head and they've got the photo, like the photo comes in and out by their movement. Like you start seeing their chair that's behind them, and sometimes you don't, depending on where they're at. I find that just a plain background, like honestly, this white board right here will be fine. Just a plain wall behind you. I think you should not have your bedroom as your background. Like just find a corner. It could be a brick wall. Go to the library, wherever.
Also, another thing you can do on Zoom with your background is just blur it so that
it's
basically the same effect. So if you have a little bit behind you, it
Yeah,
doesn't.
yeah. I feel like blurring is better than having a photo. Just because what ultimately ends up happening is you move around, and what's behind you comes in and out, or your ears disappear. It's it shouldn't matter, but if you're trying to impress somebody and they're focused on ears are gone, ears are here, ears are gone, ears are here, ears are gone, they're not paying attention to your message. And so I recommend, like you see my YouTube videos, that's, I'm sitting on my porch, there's a wall behind me, it's just a window to a bedroom and nothing interesting is happening. So I feel like that's okay at work. I just have, an empty, wall behind me that you can see a bedroom closet. There's nothing interesting happening. I don't have anybody walking by, but I also don't have anything like personal. Like I keep, you don't know what people have for hangups on what they like and they don't like. And so I always try to keep it so like anybody could be sitting in that position and you have any like, preferences or beliefs or prejudices, you're not going to be able to use those like right now. Like if you had a piano behind you and the person absolutely hated their piano lessons from when they were in the 3rd grade, like even though you're passionate about it, even though you're a great pianist, that could be something bad that just here clicks. So other questions? That was kind of a long rant, but.
And then I emailed you earlier a question regarding the due date scheduling with it. So on Canvas, it's listed as due the 21st, but you also say that we have to like schedule a specific.
Oh, okay. I cancel that's a copy and paste. I missed that from the previous one. I want everybody to get it in. So I need time to be able to grade because reading your papers and going over your videos does take some time. So I need a little bit of lead time for me to be able to reach my deadlines. And I will go through. This is I scrutinize your projects more than I scrutinize your homework, and that is out of when it's your project. You need to bring in one of your strengths. So like if, let's say that you're coming from, like a communications background, you're in graduate school because you want to retool yourself. I feel like I shouldn't hold that person coming from like psychology or communications to the same level as, the computer science major or the stats major coming in. So I really want you to be focused on learning, but when it comes to your projects, like you can pull in your backgrounds, you can pull in subject matter knowledge or a mathematical background or a computer science background into your project. So you can make yourself shine. I give you the flexibility to go, hey, I'm stronger in subject matter knowledge than I am on statistics. I'm going to do a better subject matter knowledge presentation. You can use anything as long as it's a data science project. The goal is to do a professional level job. And so you can pick, imagine that, so if you have a strong computer science background, maybe you want to do something that is stronger on the computer side. Maybe there's an algorithm that hasn't been like coded up yet, that there's an academic paper on it. You can do that. Maybe you have stronger subject matter knowledge. Let's say you have a strong psychology background and you want to do psychometrics. Well, then, talk about the psychology leading into it. And there, your statistical models won't be as advanced, but you'll be presenting why this is interesting, why this is informative. 2 very different projects, but these are both data science projects. And so I want you to, do something that, like, to me, ideally, I would like for you to complete this project so that when you need to be able to talk about what you've done in the past, this can be something that you immediately bring up during that job interview. That's really what I want to see. That like that level, like they start grilling you, like what have you done? The big companies, they can honestly, they can be pretty arrogant. They can act like you have no background and because to make themselves feel good. I've been in that position. If you've got projects under your belt, you can say, well, I did this X, Y, and Z. I did this X, Y, and Z. I want you to have this project as one of those, so that you've got something to say.
That due date, that's next week, right? The 21st, I want to say.
Mhm.
So I'm assuming that 21st due date, that's concrete, got to be in by then.
It's got to be in by the time I am sitting down grading. So, all right. So I just need enough time to get through everything. If I don't have enough time, and you're the last one to submit, your grade's gonna drop. I have never failed a graduate student. I've never failed a student in a 5,000 or 6,000 level class. In the realm that I was in, a C was equivalent to failing. Basically, this was the math department in Gainesville. If you got a C, that was basically the professor saying you need to choose a different course in life. But the professor didn't want the headache of dealing with you losing your funding, like directly. So if you got less than a C from me, you have to really, really get under my skin. I've never given anything less than a C to a 5,000 level student. So if you are late, that's your worst case scenario. Because and one of the reasons why I do that is I want this course to be about learning, not about oh, I have this assignment, I'm going to rush through this. Okay, you need an extra day and a half to get through a project. Take the day and a half. I'm not sitting there waiting for 11:59 at night, ready to grade. It's enjoy it, appreciate it, do your best work is what I want.
We can even use Zoom to do this recording and this case,
Yeah, so
preferably stand record
yeah, so it is ucf.zoom.us and sign in. It'll be your NID and NID password. So for me, it's my web courses information.
When you're doing that, though, you have to edit, you have to splice together stuff or make cuts. Or
I could if I wanted to, but
you just single take.
I usually single take, but you can stop the video and you can stop the recording.
I'm not going for hit that like and subscribe button I just didn't know.
Yeah, I know what it's like to speak. I know what it's like to be recorded. I'm not going to sit there in a public speaking class and with a counter on your number of ums. You can botch it horribly. I'm looking for you more than anything. Did you do the project? Did you find a way to show me something interesting? One thing, okay, so something that is absolutely critical, thing I want to see more than anything, I want to know why you did what you did. I've had students who did presentations who did exhaustive analysis of the residuals of their linear model. Why? And I couldn't figure it out. And I think that, I believe the student took my code, copied, pasted, dropped data set in, and just basically just repeated what was on the screen. And that's not what I want. I want you to be I did this because of this and that. The project can be actually pretty quick and easy as long as you have a firm idea of, I saw this, I'm going to do that. And you can tell me, I explored these options, but they did not work out. Let's say you tried something, you tried a model and it wasn't very strong. Tell me that. That's good. Knowing that, or, I did this model structure and it was just a poor fitting model, therefore I threw it away. that tells me you're going through the right process. So the like why you did it is important. Pretend that I am a decision maker at a company. And that might be, I might be the head of data science, I might be the head of marketing. You pick me to be whatever role would be appropriate. And I'll pick up on what you're throwing at me. I just need to know that, like why, like everything needs to be purposeful. If it isn't clear why you did something, it shouldn't be in your presentation.
Any format that you'd like to see on the write-up?
I like visualizations. I like visualizations up, down, left, and right. We think with our eyes, take advantage of it. Oh, also something I need to say. Okay, guys, I will penalize your grade for your attire, but ladies, I have no idea what truly constitutes business formal. So, ladies, you pretty much get 100% on that because it's so much more so men and women are held to different standards on this. Like men, we could wear the same suit every day and no one will criticize us. But women, you need to wear something fashionable and different every day. You have to rotate through. This is like the one time that the ladies get a fashion pass and the guys do not. So, guys, just wear a tie.
Different definitions of business formal for women,
Yeah,
where for guys, I feel like it's the same definition.
yeah,
So it's tricky.
yeah. I just accept it. Honestly, whatever you're wearing is business formal for that day because, women, it's just like a wider range because you're more judged on what you do over time, while guys are judged in the moment, I feel like. All right, if that is it, then we will go ahead and call it a night.
Thank you.
Take care. Have a nice evening.